Hey everyone, welcome to today's lesson about finding patterns in nonlinear functions. In today's lesson, we're going to be looking for patterns and we're going to be talking about what happens when I make a graph and it doesn't make a straight line. That's what we call a nonlinear function. So, in each example, we're going to plot some points and we're going to look, does it make a straight line or does it not? If it does not make a straight line, we know there is no constant change, and it is then a nonlinear function. We're also going to be looking for patterns and trying to come up with a rule for nonlinear functions. Let's look at the first example. In the first example, we're looking at the area in square inches of a pizza. The table at the right shows the radius and the area. Let's start by graphing and we'll determine whether it's linear or nonlinear. So, I'm going to make my set of axes. I'm going to label the x-axis with the radius and the y-axis is the area. That's because the radius is my independent variable and the area is my dependent variable. So it looks like I can go by 2's across the x-axis, 2, 4, 6, 8, and then 10. And then on the y-axis, the area goes all the way up to over 300, so I should probably be going by, we'll say 50s. So 50, 100, 150, 200, and so on. All right, now I'm going to start plotting my points. When the radius is 2, I'm way down here at 12. When the radius is 4, I'm up here at 50. When the radius is 6, I'm up over 100. When the radius is 8, I'm up over 200 now. And when the radius is 10, I'm up in the 300s. So we can see that this starts off slow and then gets big very quickly. This is not a linear function because the graph does not make a straight line. All right. That's a backwards N. There we go. Moving on to example 2. I'm going to take it one step further. I need to now find the pattern and then we'll identify whether it's linear or nonlinear, and we'll explain this using words, a graph, an equation, and we'll finish the table. All right, so we're looking at a set of cubes. So I've got one cube and I can see the total number of blocks, and then if I have 2 cubes on an edge, what's the number of blocks? And then if I have 3 cubes on an edge, what's the number of blocks? So I can look at the table. They've got us started. If I have 1 block on an edge, the total number of blocks is 1. If I have 2 blocks on an edge, I have now 8 total blocks, and if I have 3 blocks on an edge, I have a total of 27. So let's kind of look at what's happening here. It looks like if I'm really finding the volume. So if I look, I have the length, the width, and the height. So that's 1 times 1 times 1 to find this first block. In the second, I've got 2 times 2 times 2, and that gives me 8 total blocks. In the third case, I have 3 blocks on an edge, so that's 3 times 3 times 3, and that gives me 27. So to find 4, I will have 4 times 4 times 4, which would be 64. And that ordered pair is the ordered pair 4, 64. And then for the case of 5, now I have 5 across the bottom. 5 is the length, and then 5 is the height. So it would be 5 times 5 times 5, which is 125. And that's the ordered pair 5, 125. So the equation here would be y equals x to the third power, because each time I'm multiplying the blocks on one edge by itself 3 times. So the equation would be y equals x cubed. The graph of this, and we're going to go ahead and just sketch this. If I have 1, 2, 3, 4, 5, and then I'm going to label by 20s on the y-axis to show the growth. All right, so if I have 1, I'm way down here at 1, over 2 up 8, 3 up 27, 4 up here to 64, and as I start to grow up, you can really see how it increases very quickly now. This is non-linear. And to explain this in words, I could say the total number of blocks is the number of blocks on one side raised to the third power. All right. Let's look at one more example. If I'm given this set of ordered pairs, I need to try to find out what's the pattern and then write a rule. The best thing to do first is to create a table. So I'm going to make a t-chart of my x and my y values. So 1 goes to 2, and if I plug in 2, I'm going to get 4, and if I plug in 3, I'm going to get 8, 4 and 16, 5 then goes to 32. So I need to try to find some sort of pattern that links these x and y values. Let's start by looking at how I could get from 1 to 2. Well, I could do x plus 1. Let's see if that works for the second case. If I plug in 2 and I do 2 plus 1, I do not get 4. So I'll try something else. I could do x times 2. That would give me from 1 to 2. I can plug in 2 and I get 4. That works. I could plug in 3. 3 times 2 is 6, and it's not 8. So that one gets crossed off. Another way, and this is a little bit off the beaten path, I could do 2 to the first power. I could do 2 to the x power. So if I do 2 to the first power, that's 2. If I do 2 to the second power, that's 4. If I do 2 to the third power, that's 8, and it works all the way down through here. So my final answer is y equals 2 to the power of x. This is very common when I don't have a linear function to check for repeated multiplication. And remember, repeated multiplication gives me exponents. All right, now it's your turn. Flip to the back and do the self-quiz, and then check your answers. All right, question number 1. It says I have a radius, and then I have the area. Is the function linear or nonlinear? Well, I can look for the change here. I noticed I multiplied by 4 to get here. But if I multiply by 4 again, I'm not going to get 9 pi. So this is non-linear. And the reason is there's no constant change. If I graphed each one of these points, I would see that the graph is not a line either. All right, in number 2, I've got some ordered pairs and I need to write a rule. So let's start off by making a table. X and Y values. 1 goes to 4, 2 goes to 7, 3 goes to 12, 4 goes to 19, and 5 goes to 28. I need to kind of exhaust all of my possibilities. This is a tricky one. We find out that the rule is y equals x squared plus 3. If you didn't get that, go back and try to find if you can make x squared plus 3 work in here. That is the pattern. In question number 3, the function shown by the table below, is it linear or nonlinear? I'm looking for a constant change, so the change from 4 to 8 was 4. The change from 8 to 16 is 8. I can stop right there. This is not a constant change. Therefore, this is non-linear. All right. If you think you need a little bit more practice, you could skip down to the problems below and see if they are linear or nonlinear functions and work on finding some patterns. If not, come to class ready to work.